All right, so the last set of formulas that we're going to need to know for this unit and for this semester are called the double angle formulas. So what I want to start by doing is kind of show you how we get them, because that will help you maybe figure out how, or see how you could always do it another way if you forget these formulas. So double angle is what happens when you have 2 times something inside of your sine or cosine or tangent. So I want to think about how we could rewrite this. We could rewrite this as sine of theta plus theta. So if we take our double and just separate it into the theta plus theta, then we have our angle addition for sine. So if we use our angle addition for sine, we end up with sine theta cosine theta plus cosine theta plus sine theta. Oh, not plus, times. Well, when we write it out using our addition formula, we end up getting sine theta cosine theta plus sine theta times cosine theta. We can combine those to just be 2 sine theta cosine theta. This right here is our double angle formula. So we know that this is going to equal sine 2 theta. So what this one formula lets us do is bypass all of this and just know that sine of 2 theta will equal 2 times sine theta cosine theta. So this right here is our first double angle formula that we could use. Our second one is for cosine. So what happens when we have cosine of 2 times an angle? Well, again, we can rewrite that as cosine of theta plus theta. Actually, oh, never mind, yeah. So then using our formula, we can say that, or for addition, this will be cosine theta sine, nope, cosine theta cosine theta, not sine, minus sine theta sine theta. Well, 2 cosines being multiplied, that's cosine squared theta minus sine squared theta. Okay, this right here is our first form of the cosine double angle. Now, one of the things with cosine, though, is that we actually have more than one form it can look like. So this is one form, one formula, but what if we do some Pythagorean identity substitution? So let's say I notice that, hey, what if I, instead of writing sine, what if I change that, instead of sine squared, I change that to 1 minus cosine squared. When we distribute the negative and combine our like terms, we get 2 cosine squared theta minus 1. This is another form of our double angle for cosine. So a double angle for cosine can be written this way, or it can be written this way. Now there is a third way that it can also be written. Our third way is to say, what if we take the same starting point, so I'm going to do this over here, and instead of doing our Pythagorean identity and substituting it in for sine, what if we did it and substituted it in for cosine? We would get 1 minus sine squared theta minus sine squared theta. So this right here was what we substituted in for cosine squared. When we combine like terms, we end up with 1 minus 2 sine squared theta. This is our third form of cosine double angle. Now, because we have multiple forms here, we kind of have to use the context of the problem to help us decide which form we're going to actually use for our given situation. And so we'll talk about that when we do some examples, how to tell maybe which form, and you might have to try one and see if it works. And if it doesn't, go back and try another one. There's no steadfast way that will always work. You kind of have to look at your problem and decide which way will work. Okay, so we have our one double angle for sine. Cosine double angle has three different forms. Tangent, our third one, tangent of 2 theta. This one only has one form. So if we look at this one, and again, start by writing it out as tangent of theta plus theta, because that's how we get 2 theta. And we use our addition formula, so that would be tangent of theta plus tangent of theta over 1 minus tangent of theta times tangent of theta. When we combine like terms, we end up with 2 tangent theta on top and 1 minus tangent squared theta on the bottom. Here is your tangent double angle formula. So what we're going to be doing tomorrow, as well as on Friday, is we're just going to be working with these formulas in addition to working with the angle addition formulas to continue to solve and simplify different trig expressions. So let's go through, I think I wanted to do 4 here, and then we'll do 5 or 6 in class tomorrow to make sure we've got double angle formula down. But I did want to go ahead and try to do 4 here with you, just so that you could kind of see what they look like in the context of a simplifying problem. All right, so our directions here are just to simplify, so we're not solving, we're just going to simplify. So when we simplify, we try to look to write our trig expression as small as possible and with as few trig functions as possible. So our first one here is 2 sine of 50 cosine of 50. So again, I'm going to look up to my formulas to see which one could it potentially match. So I know I have a 2 times a sine times a cosine, and my angle's the same. So which of these show me 2 times a sine times cosine? So when I look through, the only ones that have both sine and cosine are this one and this one, but this one's subtraction, so that means it has to be a sine. So what I'm going to do is rewrite this as sine of 2 times theta. And in this case, my theta is 50. So this is going to equal sine of 2 times 50, which is sine of 100. And that's as simple as it gets. For our next one, we're doing the same thing. We have cosine squared 7 degrees minus sine squared 7 degrees. So which of these does it match? And we're going to these are working backwards, if you want to call it that. So when again I look through my double angle rules, a sine and a cosine, that narrows it down, you can't see that top one anymore, narrows it down to these two. And which of those two has a subtraction in the middle? That's my cosine double angle. So that means this is going to equal cosine of 2 times 7, which is cosine of 14. Our next one that I wanted to do with you is 2 sine squared 35 minus 1. So when I look at this one, and I look to see which of these does it match, it doesn't really match any of them exactly, but it's really close to this one that goes with our cosine double angle. The only problem is that here the 1 is positive and the 2 is negative, whereas in my situation, my 2 is positive and my 1 is negative. So if I were to factor out a negative 1, I can switch my signs, which now this matches my cosine double angle. So in place of all of this, I can put cosine of 2 times 35. So that would give me negative cosine of 70 degrees. And that would be as simple as we get. So on some of these, you might have to tweak it by either factoring out a negative or something like that to make it look like one of our double angle formulas. Okay, the last one that I wanted to do with you guys, might help if you can see, 2 times tangent 100 degrees divided by 1 minus tangent squared 100. So on this one of the nice things about tangent is usually your formulas that contain a tangent have to come from a tangent. So I'm going to just double check, does this match my rule for tangent 2 theta exactly? 2 tangent of my angle over 1 minus tangent squared of my angle, it does. So that means I can rewrite this as tangent of 2 times 100, which means I'll have tangent of 200. Okay, when we get into class tomorrow, we're going to do a few more of these where we might have to do a little bit of tweaking like we did on the third one. And I'm also going to kind of throw in a proof of using one of these just so that you guys can keep those wheels turning about how to verify and prove. So this is 6.4. We are going to do watch the second video tonight, 6.5, which continues with more of this double angle, and it goes into some different scenarios. So go ahead, stop this one, write down any questions, and when you're ready, go ahead and watch 6.5.